Hello, in this module, we will talk about Oracle Cloud Infrastructure, OCI, and the important networking constructs you should be aware of in the context of this cloud. First of all, let's take a look at the hierarchy of your cloud account in OCI. At the very top level, you will have the account, which in Oracle is called tenancy. This is your root compartment. Then all of the other resources that you are creating in OCI are aggregated into compartments. Those compartments resemble to some extent the resource groups you may know from Azure. One interesting thing about OCI is that there exists a concept of the home region. This is the region where all of the information, the metadata about your tenancy, all of your compartments is held. This is not present in other clouds. You will be asked to select your home region whenever you are building your OCI tenancy. Rest in mind, you can obviously create resources in all of the regions, not only in your home region, but you need to specify which region will be considered the home region for you. Now, as you navigate through Oracle OCI UI, you will see that the services are distributed across a number of categories, which are quite standard at this point in time. These are compute, networking, storage. There is a big section of databases in Oracle. As you can imagine, that's one of their key selling features. So lots of focus is placed on the databases themselves. What are the important components that you should be familiar with? Their names. First of all, we have compute. This is how you will be referring to the virtual machines that you are running inside Oracle. Then you have IAM to control the privileges and the access management for different resources and users. The important name to remember is VCN, Virtual Cloud Network. This is similar to VPCs and VNets in other clouds. You have block volume, which is the storage service. You have Fast Connect. This is the private circuit you will be getting from your on-prem data center to Oracle Cloud. And then you have DNS zone management for DNS services. Let's take a look at a quick build out of the standard OCI network. First of all, you will select a region where you want to deploy your network in the VCN. Then you would deploy the VCN specifying what is the CIDR range of that VCN. In this example, it's 10/16. Inside VCN, you deploy subnets. And now an interesting twist in OCI is that a subnet can be regional. So you mark the subnet as available in all of the availability domains, or you can limit your subnet to a specific of the availability domains. Each of those scenarios has its benefits and trade-offs, but this is different than any other cloud, so it's worth noting. As you are selecting a place to deploy your instance, you still have to select one of the ADs or let Oracle select the AD for you if you're working with a regional subnet and you want let's say, the random assignment of the AD to happen. Similarly to other clouds, you have ways of securing the access in and out of the resources of the instances that you are deploying in OCI. There are two concepts here: security list and network security group. Security list is similar to other clouds as a layer 4 firewall, which allows you to control what is the traffic allowed for inbound and outbound access. Whenever you create a subnet, there is a default security list created for that subnet and automatically associated with it. And in that default security list, you will have a few predefined rules already implemented. You can keep on adding your own security lists, or you can keep on modifying the default security list with the new rules. What's worth noting, each rule over here can be stateful or stateless. You decide whether you want to explicitly configure and allow both flows of the traffic, the ingress and egress, or if you want to use the stateful rules, then you just need to specify one direction of the traffic and the other one would be allowed by default. So as I said, security list applies to the subnet level. So all of the instances in that subnet would follow the same configuration. If you want some more granular control for the instance or group of instances, but not the entire subnet, you have the concept of network security group, NSG. You see it marked here with some of the instances. This is an optional entity. You do not need to apply NSGs to your instances. You can rely only on the security list. But as I said, if you need more granular control, go ahead. There is no network security group created by default when you build a subnet or create an instance. So it's all up to you to add it afterwards. Whenever you're creating a subnet, the other default thing which gets added to it is the route table. Route table is similar to what you've seen in AWS, for instance. So it defines what is the next hop for specific destination side. Default route table is empty. It's created whenever the subnet is created, and you can keep on modifying this default route table with your own entries. On the other hand, you can create your own route tables, your custom route table, and keep on modifying them as well. There is no real difference between the default route table or custom route table. Whenever it comes to public internet connectivity, you have the internet gateway. That's the entity which allows the traffic to go in and out. In OCI, we have the concepts of private and public subnets. You actually need to define a subnet to be private or public at the time of creation of that subnet. It's not like AWS, where simply your subnet is considered public whenever it has a quad zero route pointing to the internet gateway. In OCI, it's slightly more strict. You need to configure it at the time of creation of the subnet. And what it does is simply makes it possible or impossible to assign public IPs to your instances. In a public subnet, you can assign public IPs to your instances. In a private subnet, it's not allowed, even if you try. Internet gateway, that's one of the very important gateways that you should be aware of in the context of OCI. It's similar to internet gateway in AWS. Then we have dynamic routing gateway, DRG. This is a VPN gateway used in OCI. So if you need to build an IPsec tunnel to any external network, to your on-prem or maybe to other cloud, you will be terminating the IPsec tunnel on DRG, the dynamic routing gateway. Interestingly, the very same gateway is used for termination of the fast connect, which is the private circuit available in OCI to connect you directly with your data center. So now let's summarize different types of gateways that we have in Oracle Cloud. First of all, we have dynamic route gateway. We just mentioned it. This is the termination endpoint for IPsec tunnels. But with the recent additions in OCI or recent changes in their networking, this gateway has become much more powerful. Now it does not only terminate the IPsec tunnels nor fast connect gateways, but it also becomes a hub transit solution, if you will, for interconnecting VCNs in Oracle. We will talk about details in the next slides. But keep in mind now, it resembles much more now something like AWS Transit Gateway, their AWS TGW. The functionality, as you will see soon enough, is fairly similar. Apart from DRG, we have Service Gateway. This is a gateway used to allow your resources in the VCN to access Oracle publicly available PaaS or SaaS services, but using private IPs without actually going out through the public internet. Then we have Internet Gateway and NAT Gateway. Both Internet and NAT gateways are used to access the public internet resources. Using Internet Gateway, you need a public IP address assigned to your instance, whereas in NAT Gateway, you can access the public internet resources, but only in the outbound way, so that your VM reaches out to them. The bidirectional access, let's say, is not available. And when you're using NAT Gateway, your instances, your computes can reside in a private subnet, and they do not need to have a public IP assigned to them. There is still a local peering gateway, which is used for, let's say, VCN peering inside a region. But with the recent changes to DRG, the dynamic routing gateway, the local peering gateway and the local peering connection itself, the VCN peering, becomes kind of obsolete. I'm not saying this is officially deprecated, but you have a much better option now through dynamic routing gateway. So I don't see many reasons to keep on using LPGs. Subnet in OCI can span a single or multiple, all availability domains available in a specific OCI region. So this is a slightly different flavor of the subnet compared to other clouds. Route tables, they specify what is the next hop for your traffic. But in Oracle, it's interesting that you can assign a route table to an attachment entity to handle the ingress traffic routing. Let's say from the DRG attachment on your VCN, you can assign this route table to handle the ingress traffic for the traffic coming from the DRG. So this is interesting, and no other cloud supports those types of easy configuration of the route tables, especially for the ingress traffic. And obviously the route table supports all of the intra VCN traffic as well. It is assigned to a subnet. Now let's take a look at the new version of DRG. It has become globally available on June 1st, 2021. It has become a hub solution, which allows you to interconnect up to 300 VCNs, up to 300 IPsec attachments or fast connect circuits. It allows you to guide the traffic, let's say, through a firewall for an additional firewall inspection as the traffic goes from one VCN to the other, or from one VCN to your external networks, like a data center over fast connect, for instance. Obviously, managing this at scale, especially all of the route tables, is quite complex. But having said that, this has become a really nice transit solution for OCI. So let's take a closer look at some of the details here. First of all, what you need to know about DRG is that it supports 4 types of attachments. First of all, this is the VCN attachment, so attaching your VCN to this hub solution. Then we have remote peering connection attachments. What it effectively becomes is a DRG peering. If you want to peer networks in one region with networks in the other region, then you would now create a DRG in each of those regions and then establish this remote peering connection. As I said before, this is effectively a DRG peering now in OCI. And with this, you allow the communication to go from one region to the other. And what is also good to note is that you can have multiple DRGs within a region, and those DRGs within the same region can be peered with each other. You can establish this RPC connection between DRGs within the same region. Then we have IPsec attachments and fast connect attachments. So connecting to any external network is available towards the DRG as it was before. Inside the DRG, you can configure multiple route tables. This would allow you to create some form of isolation of the traffic between different VCNs or between different external connections. You could create those types of security zones or security domains, if you will, inside DRG. When you create a DRG, there are always a couple of auto-generated route tables already available for you. One is dedicated to VCN attachments. The other one is dedicated for all of the other types of attachments. But obviously, you can keep on creating your own route tables and assign different attachments to different route tables to create those types of security segments or different routing domains, if you will, inside such a DRG. What is helping you manage the route tables inside the DRG are the services of route import and export. Route import is basically allowing you to insert automatically into the route table of the DRG the CIDR range, which is associated with the attachment that you assign to that route table. Let's say you associate a VCN and create an attachment of the VCN to a DRG. You can have the CIDR range of that VCN, or to be very exact, the CIDR ranges of the subnets without that VCN. You will have them automatically imported and inserted into the route table of the DRG so that the traffic coming from different attachments will be routed towards those destinations automatically, or let's say that the route table entry is created automatically. So it helps you with some forms of route propagation for exchanging the different CIDR ranges from different attachments into the route table. And then let's say on the symmetric side of things, you have the route export, meaning that if your DRG has a number of CIDR ranges in its route table, and that route table is now associated with a specific attachment, like let's say IPsec tunnel going to your data center using BGP, then those CIDR ranges available in the route table will now be exported over BGP to that external network, and this is route export. What is worth noting is that, as you see here on this diagram, you have route table on the DRG side, but also you can have a route table associated with this attachment on the VCN side, and it allows you for some more transitive configuration of the routing, because now the traffic coming from DRG into your VCN can be routed on the ingress part according to your specification. You can override some of those behaviors that automatically would be happening inside the VCN. This is a view of a route table inside DRG, where you see a number of attachments and different types of those attachments, and you see all of those routes here are created dynamically thanks to the automatic import of the routes from the attachments. So you will see the CIDR ranges of the subnets inside 3 VCNs. Then we have CIDR ranges imported from another DRG, which we are peered with. And there are actually 2 DRGs that we have peerings with. And finally, we have the routes coming to us from the external network advertised over BGP over IPsec. A couple of other interesting elements you may notice here. First of all, one of the DRGs that we are peered with is actually residing in that very same region as the DRG that we are looking at. So it is possible to peer DRGs within the region. Then it's also important to note that you can enable eCMP on the routes. I have 4 tunnels going to my data center, all of them advertising the same prefix to me, and I can use eCMP to load balance the traffic across all of those 4 tunnels. There are many more details about DRG that you may learn from Oracle sites, but we're just giving you here the highlights. Then a quick zoom into Oracle Fast Connect. Fast Connect, this is the private circuit that Oracle offers as a way to interconnect your data center directly with OCI resources. And there are 2 types of peerings available on OCI Fast Connect. The first one, this is private peering, giving you the access to your VCN resources over private IPs using DRG. And then you have a public peering, the second type of peering, which allows you to access Oracle's publicly available PaaS or SaaS services using this dedicated link. And also with public peering, you can access your own resources in your VCNs, assuming that they use public IPs. And obviously the link by default has good stability, low latency, and the throughput can be quite high depending on your needs. You can control it quite granularly. Now a quick summary of OCI networking. Definitely the recent improvements of the DRG have increased the usability of DRG. And in principle, it made Oracle's native networking much better than what it used to be. And also what's worth noting, the DRG, all of those networking services, the DRG attachments and so on, they are free of charge. So you actually only pay for the data which is going out to the public internet. So that would be your egress charges, or those would be also the IPsec tunnels that you build from the DRG into your data center. But otherwise, all of those services are free, including data over Fast Connect. But what is the challenge? I mean, the biggest challenge is that DRG is a solution available in Oracle only. You should all know by now that sticking to services which are available only in a single cloud when it comes to networking and connectivity, this is not the best idea. We always believe that every company will become multi-cloud at some point if they are not there yet, and they should not be focusing on solutions which are tied to one specific cloud. Another important element worth noting is that there is no encryption available for you to enable. There are some places where Oracle offers MACsec type of encryption, but this is not something which you as the end customer controls. If you need to implement, let's say, encryption over IPsec, which you control with your certificates, then this is not something which is available in OCI. Other types of limitations, as in the other native cloud constructs, you have limited visibility. You don't know why exactly one specific route is becoming the best route out of the many potential options that are being advertised to your DRG. You don't have a full-blown traffic visibility into everything that is passing your DRG or your VCN attachments. You don't have easy way to control the route advertisement from the perspective of things like metric or AS path length and so on. So sometimes it might be difficult to guide your traffic the way you want it to, when it especially has to come from your data center into Oracle. Then you remember we've been talking about route import and export from a DRG. And one thing which is missing, and it seems like it would be a good addition, maybe Oracle will add it in the future, the route export towards a VCN. What it boils down to is that even if you have all of the routes nicely configured already inside the route table of your DRG, and you attach your VCN to that DRG associated with the right route table, you still have to go into the route table of the VCN and create a route entry pointing specific CIDRs towards the DRG attachments. This is not happening automatically. So even if everything else inside DRG is happening kind of in an automated way, the first hop for the traffic from your VCN out into the DRG, you have to configure that route table entry on your own, which makes it, difficult to troubleshoot, prone to errors. Some fat fingers may disrupt your networking because this is a part that you need to make sure is configured right. And at a bigger scale, this type of management can get quite difficult. All right, thank you. Now off to the next module.